there are multiple charges are there in a space at a point P. Suppose हमें potential निकालना है. Suppose these charges are Q1, Q2, Q, like multiple charges are there, and this P is at a distance R1 from Q1, R2 from Q2, and R3 from Q3. ऐसे करके तो potential at P due to this Q1 is, वो वाला फॉर्मूला अभी अभी पढ़ाया था, V is equal to K Q by R. So potential at the point P due to Q1 it is K Q1 by R1, like that. Due to point charge Q2, potential at P it is K Q2 by R2, like that. So if I add all this, we get the total potential, but net potential at P is sum of all this, which is called superposition principle. So V is V1 plus V2 plus dot dot dot. So I can add all this K Q by R1 plus K Q by R2 plus dot dot dot. तो ऐसा एक न्यूमेरिकल एक्सरसाइज में है, वी कैन सॉल्व दैट वन. द न्यूमेरिकल इज के देयर इज ए रेगुलर हेक्सागन, on that hexagon at all the vertices a charge of 1 microcoulomb is placed, 1 microcoulomb, and the hexagon has a size of 1 centimeter. 1 centimeter, say all sides are 1 centimeter. So in that question we are asked what is the net potential at the center of that hexagon. So since center means if we join all these opposite edges, we will get the center of the hexagon, and see all the triangles formed are of equilateral triangle because we have taken a regular hexagon. So that means all sides should be 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, like that. So at this point at the center, what is the, if this P point is P, you can find it out. Please find it out. So there are 6 vertices, 1, 2, 3, 4, 5, 6. That means V is V1 plus V2 plus V3 plus V4 plus V5 plus V6. So all are of same potential. So you can multiply it. There are 6 potentials, V3, V4, V5, V6, like this. So all are of equal value. So 6 times of K Q by R. So 6 into K is 1. It is K value. When yesterday I said ना, जब न्यूमेरिकल करेंगे K का वैल्यू हमें लिखना है 9 into 10 to the power 9, and charges are of 1 microcoulomb, so 10 to the power minus 6, and the distance is 1 centimeter. That means 0.01 meter, like that. So you can solve this one. That is 6 9 ja 54 into 10 to the power 9, और यहाँ से 10 to the power minus 6 और नीचे 10 to the power minus 2 है. 1 सेंटीमीटर मीन्स 10 to the power minus 2. तो ये ऊपर जाने से 10 to the power minus 4 plus 9, तो 5. So 54 into 10 to the power 5, and potential unit is volt. Okay. I forgot to say one thing, that the SI unit of potential, SI unit of electric potential is volt. So the potential comes from the topic that amount of work done, potential is, you might be knowing that it is the amount of work done in bringing a unit positive test charge from infinity to a given point in an electric field. In an electric field, अगर एक टेस्ट चार्ज को मुझे लाया जा रहा है इंफिनिटी से एक पॉइंट r डिस्टेंस में, तो वहां पे पोटेंशियल है W by Q0. तो दिस इज द बेसिक डेफिनेशन. तो यहाँ से अगर वर्क डन 1 जूल है और टेस्ट चार्ज अगर 1 कूलम है, So the unit becomes 1 volt. That means when 1 coulomb amount of test charge is brought from infinity to a given point in an electric field, and for doing so, if the work done is 1 joule, so potential at that point is said to be 1 volt. Any doubt? Okay, let us proceed to our next. That is another one. That what is the relation between electric? What is the relation between electric potential and electric field intensity? So the electric potential for a point charge, suppose V is we need V, na? So for a given source charge, if we want a test charge from infinity at a distance, say x somewhere, at a distance x somewhere, say the test charge is here. So at that point, the electric field intensity is 1 by or say k q by, if this charge is q, so you all know that it is k q by x square. So at that point, suppose a small work done is involved. That small work done is say dw is involved in bringing the test charge a little bit more with a uniform motion. So that work done is actually f dot, and this displacement, if it is dx, so we know that it is f dot dx. So this dw is f dx cos 180 degree, because the force is against the test charge. Test charge is to be negative. So the angle between that okay, to let us do like that one. The electrostatic repulsive force is this side, because this positive source charge will repel it, and the positive test charge we are bringing along this direction, opposite to this one, na? And that magnitude of the force is equal to F. So it is displacing along the direction of this F, and this F must be is equal to the electrical force, that is K Q into Q0 by X square. Uh, is it clear? The electrical force is K Q into Q0, the distance is X, K Q into Q0 by X square. And the same amount of force we are using here. So somebody may be thinking that the दोनों फोर्स तो दो तरफ है, दोनों फोर्स दोनों तरफ है, लेकिन फिर भी कैसे डिस्प्लेसमेंट होगा? So net force zero means it is not always at rest. Net force zero means we can bring this test charge with a uniform motion, because uniform motion means net force zero, because uniform motion means acceleration zero, and acceleration zero means net force is also zero. So by uniform motion we can bring this test charge. So if I use this force is equal to the electrical force, then it is F dx cos 0 degree. So it is F dx. Now this work done in doing so, it is q0 by okay, we can put it later on, F dx. So total work done, if by doing so, if the total work done is integration dw. So when we do integrate it, we will be getting that the answer comes out to be that one, that k q into q0 divided by k q into q0 divided by x. We will get this one formula. So work done के नीचे अगर q0 ले आया, so it becomes k q by x. Okay, integration is from infinity to the, suppose here we want to find where the distance is r, तो अगर integrate infinity से r तक करेंगे, so the answer comes out, it is r. Here it is r. So this work done by test charge is, as I said, it is the potential. So potential comes k q by r, like that one. So this is about the how we can find out the potential by using electric field intensity. Now my question is this one, that what is the relation between electric field intensity and electric potential? So in doing so, if I show that dW F आगे से कुछ मैसेज है नहीं है. Am I audible? पावर कनेक्शन चला गया था कुछ सेकेंड्स के लिए. Okay, so the work done, always remember this formula. Work done is minus f dx. So dw is equal to minus f, मतलब the relation between what is the electric field intensity is f by q0 na. So I can write, instead of f I can write q0 into e dx. So my suggestion to you people that whenever the relation between electric field intensity and potential is asked, always remember this formula, that dw is equal to minus q0 e dx. तो यहां से दोनों रिलेशन आई कैन ब्रिंग द रिलेशन. देखो dw के नीचे अगर q0 आ गया तो इट बिकम्स पोटेंशियल, तो इट इज माइनस dx. सो dw work done per unit temperature is potential. So since यहाँ पे d लिखा है तो let us put dv. तो dv is equal to minus e dx. So see, e can be written as minus dv by dx. So this is one answer, that electric field intensity is equal to negative gradient of potential. और अगर कोई दूसरा तरह से लिखना चाहते हैं तो आई कैन राइट इट एज, देखो यहाँ पे देखो इस तरफ में अगर सी दिस फॉर्मूला dv इज इक्वल टू माइनस ई dx जो है इसको मैं इंटीग्रेशन कर देता हूं. v इज इक्वल टू इंटीग्रेशन माइनस ई dx. तो दिस इंटीग्रेशन इज called the line integration because integration is done along the length dx 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 dx. So that's why see this is integration dv is actually the net potential v, it is minus integration e dx. So a wala formula, this formula is also correct, that electric potential at a point is equal to negative line integral. Why line? Because dx is there, integration is done along the length. So integral of electric field intensity. ए वाला फॉर्मूला भी याद रख सकते हो, दिस इज ऑल्सो करेक्ट, E is equal to minus dv by dx. So I can also put this one. So in most of the cases we are using that E is equal to dv by dx. In that case this E is taken as the magnitude. अगर मैग्नीट्यूड ले लेंगे तो इट इज E is equal to by dx, that is differentiation of potential along the length or with respect to the distance x gives us the electric field intensity. This is a very, very important one, that E is equal to dV by dx. Next is one more topic, which is I can say that dipole. For electric dipole, as we learned yesterday, that a dipole has got a consisting of two equal and opposite charges separated by a distance 2a. So derivation part, if I go to solve that one, it will take a much time. Suppose at any arbitrary point, if we want to find the electric potential, not intensity, so which is at a say this is the center. From the center, suppose this P is at a distance r, and from the charge minus q, it is at a distance r1, q2. From positive charge, it is at a distance r2. The total potential at P becomes, I think you will have your कॉपी विथ यू, कॉपी में देख लो कि पोटेंशियल, आई थिंक ये वाला सर जो भी टीचर है वो सिखाया था कि इट इज P cos theta if this is theta, because this line joining the point P and the center of the dipole, it makes an angle theta with the direction of the dipole moment, क्योंकि dipole moment माइनस q से प्लस q होता है, so इस डायरेक्शन के साथ थीटा एंगल बनाया है. So P cos theta, P is the dipole moment divided by 4 pi epsilon naught r square एक आएगा. So this answer comes so for a dipole, but यहाँ पे condition है कि this distance r is much larger than a. a कौन सा था? a half of the dipole length, because 2a is the dipole length, तो उसका half. So r, if for a short dipole, r is much larger than a. तो last answer step में देखना, the answer comes out cos theta by 4 pi epsilon naught r square. तो यहाँ से सीखने वाला चीज क्या क्या आ सकता है एग्जाम में, कि यहाँ से पता चल रहा है कि डाइपोल होने से पोटेंशियल इज इनवर्सली प्रोपोर्शनल टू, तो डाइपोल होने से पोटेंशियल इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर ऑफ द डिस्टेंस. लेकिन अभी थोड़ी देर पहले हम लोग पढ़े थे कि पॉइंट चार्ज होने से, फॉर ए पॉइंट चार्ज V is proportional to 1 by r. So this is the difference. कि पॉइंट चार्ज होने से पोटेंशियल इज इनवर्सली प्रोपोर्शनल टू द डिस्टेंस, बट डाइपोल होने से पोटेंशियल इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर ऑफ द डिस्टेंस. दिस इज वन डिफरेंस. एंड सी yesterday in case of electric field intensity हम लोग एक्सियल लाइन और इक्वेटोरियल लाइन में भी इलेक्ट्रिक फील्ड इंटेंसिटी निकाले थे, लेकिन यहाँ पे मैं तो जनरल फॉर्मूला एक निकाल लिया. अभी मैं अगर एक्सियल लाइन में निकालना है, सो सी दिस पॉइंट शुड कम टू ऑन द एक्सियल लाइन, तो थीटा कितना बन जाएगा? थीटा विल बिकम 0 डिग्री. तो इस फॉर्मूला जिसको याद रहेगा they can do कि V is equal to P cos for axial line 0 degree, so P cos 0 degree by 4 pi epsilon naught r square. So V becomes P cos 0 means 1, so P by 4 pi epsilon naught r square. So this is the answer on the axial line. And on equatorial line, अगर equatorial line में करना है, so see theta becomes 90 degree. Theta 90 degree हो जाएगा, तो cos 90 is 0. So on the equatorial line, cos 90 मतलब 0, तो it becomes 0. So here we are getting the answer that electric potential on the axial line is P by 4 pi epsilon naught r square, and on the equatorial line the electric potential is 0. मतलब if I imagine that this is the line equatorial, everywhere the electric potential is 0. Next, yesterday one topic I taught you that when an electric dipole is placed in an electric field, in an electric field by making an angle theta. Suppose the dipole moment makes an angle theta. This is the direction of dipole moment which makes an angle theta. So torque acting was ऐसे था PE sin theta था. तो यहाँ पे हम लोग if we want to rotate, so one topic called potential energy of a dipole. Potential energy of a dipole यहाँ पे मैं पढ़ा दे रहा हूँ. Potential energy of a dipole is that the amount of work done, as क्लास 9 से लेके पढ़ाई कर रहे हो कि व्हाट इज पोटेंशियल एनर्जी, द अमाउंट ऑफ वर्क डन इन रोटेटिंग एन इलेक्ट्रिक डाइपोल इन एन इलेक्ट्रिक फील्ड इज स्टोर्ड इन द फॉर्म ऑफ, दैट वर्क डन कम्स आउट टू बी माइनस पीई कॉस थीटा आ जाता है. सो यहां से दिस वर्क डन इज द पोटेंशियल एनर्जी. तो आई कैन राइट दैट पोटेंशियल एनर्जी for a dipole, electric dipole, it is minus PE cos theta. So इसको I can write, if it is, I think if it is A, it is B, then it is AB cos theta. So you can also write it as vector P dot E. Dot product of two vector gives cos component. So PE cos theta मतलब I can also write it as P dot E. And torque जो कल पढ़े थे PE sin theta है यहाँ पे. So I can write it as P cross E. P cross E with a magnitude can also be given because no direction is given here. So I can write like this also. तो इस टॉपिक्स ये टॉपिक एक 1 मार्क का टॉपिक जनरली मोस्ट ऑफ द टाइम दे आर आस्किंग जे व्हाट डू यू मीन बाय डाइपोल इन स्टेबल इक्विलिब्रियम एंड अनस्टेबल इक्विलिब्रियम. तो ये वाला नोट डाउन कर सकते हो कि स्टेबल एंड अनस्टेबल इक्विलिब्रियम, stability gives if the potential energy is negative. So अगर ये dipole, if the dipole is along the direction of the field, अगर dipole along the direction of field मतलब इसको रोटेट करके along the field अगर दे दिया तो यहाँ पे थीटा कितना बन जाएगा, here theta becomes 0 degree. So theta 0 becomes 0. लेकिन अगर पोटेंशियल एनर्जी में हम लोग यूज करेंगे तो थीटा 0 मतलब cos 0 मतलब 1. सो इन दैट केस द पोटेंशियल एनर्जी बिकम्स माइनस पीई एंड अगर थीटा 180 डिग्री है, थीटा 180 डिग्री, इसको मैं उल्टा रोटेट कर दिया तो डाइपोल मोमेंट मेक्स एन एंगल, ये वाला ऐसे हो जाएगा. उल्टा मतलब इस तरफ प्लस क्यू आ गया, इस तरफ माइनस क्यू. तो देखो, और इलेक्ट्रिक फील्ड तो इस तरफ है, उस तरफ है, इलेक्ट्रिक फील्ड इस तरफ है. तो देखो दोनों के बीच में एंगल हो गया 180 डिग्री. तो इन दैट केस अगर थीटा 180 डिग्री है तो टॉर्क बिकम्स पीई साइन 180 मतलब भी 0. साइन 180 0 मतलब टॉर्क इज अगेन 0. एंड पोटेंशियल एनर्जी हो जाएगा, देखो पीई cos 180. अगर अभी cos 180 मतलब -1, cos 180 मतलब -1, तो देखो -1 और इधर माइनस है तो प्लस हो जाएगा, तो इट बिकम्स प्लस पीई. सो इट बिकम्स अनस्टेबल. पोटेंशियल एनर्जी कुछ भी स्टेबल कॉन्फ़िगरेशन के लिए पोटेंशियल एनर्जी हमेशा नेगेटिव होना चाहिए. अगर पोटेंशियल एनर्जी पॉजिटिव में आया तो सिस्टम इज अनस्टेबल. द सिस्टम इज अनस्टेबल. तो ये पॉजिटिव में आ गया तो इट इज अनस्टेबल कंडीशन. तो दैट्स व्हाई इट इज कॉल्ड अनस्टेबल इक्विलिब्रियम. सो एक बार पोटेंशियल एनर्जी माइनस में आ रहा है, एक बार पोटेंशियल एनर्जी प्लस में आ रहा है. माइनस मतलब स्टेबल एंड प्लस मतलब अनस्टेबल. अभी इक्विलिब्रियम मतलब टॉर्क 0. दोनों केस में देखो टॉर्क 0 is telling it is equilibrium. Potential energy minus saying it is stable. Potential energy plus it is saying unstable. Is it clear? ये वाला very very important topic है जो पूछा जाता है एग्जाम में कि what are the conditions for stable and unstable equilibrium of an electric dipole. So these two conditions are required. Somebody can draw the diagram also. Diagram दिखा देने से भी हो जाएगा. If you show the diagrams, in a diagram you can जैसे ऐसे दिखा सकते हो कि this is the direction of electric field and it is the dipole. It is minus q plus q. So it is also correct because dipole moment is along the direction of field. And अगर ऐसे करोगे, it is the electric field, and if you put dipole like this is plus q charge, this is minus, then also it is correct. The thing is that you have to understand that one, that हाँ, जैन भी ग्वालपारा कुछ से कुछ पूछना चाह रहा था। ग्वालपारा से कुछ पूछना चाह रहा था। तो टेक्स्ट में लिख लीजिए। नहीं तो टेक्स्ट में लिख दीजिए सर, टेक्स्ट में लिख दीजिएगा। Okay, let me continue. So this is about electric dipole. Then आजकल पूछा जा रहा है कि दो पॉइंट चार्ज नहीं तो 3 पॉइंट चार्ज के लिए इलेक्ट्रिक पोटेंशियल एनर्जी कितना होता है। सो पोटेंशियल एनर्जी इज द वर्क डन ना। सो अगर 2 पॉइंट चार्ज है, अगर उन लोगों के पोजीशन वेक्टर्स r1 है एंड r2 है एंड दोनों के बीच में डिस्टेंस सपोज r12 है, सपोज दिस इज चार्ज A, दिस इज चार्ज B, say it is q1, it is q2. Okay, तो इन सिस्टम में for 2 point charges, in this case the potential energy is nothing but the work done. So work done is k q, distance between these two, the distance is AB. So I can write it as potential energy is k q1 q2 divided this distance, you can write it as r suffix 12. So a wala, my request you have to recall this one, that potential energy between a system of 2 point charges is k q1 q2 by the distance. तो इसमें एक न्यूमेरिकल आप लोग कर सकते हो कि ऐसे क्वेश्चन आ गया, सपोज 2 charges, one is 1 microcoulomb, another charge is minus 2 microcoulomb, and they are separated by a distance. याद रहना है, 2 charge है 1 microcoulomb and another charge is minus 2 microcoulomb, they are separated by a distance r which is 10 सेंटीमीटर। दोनों के बीच में डिस्टेंस अगर 10 सेंटीमीटर है, इस सिस्टम में पोटेंशियल एनर्जी कितना इन्वॉल्व है। You can solve this one. K value is 9 into 10 to the power 9. It is actually 1 by 4 by epsilon naught. तो Q1 Q2 by distance, दोनों के बीच में डिस्टेंस भी दिया हुआ है, तो you can solve that one. हाँ सर, अच्छा कैपेसिटेंस के बारे में मैं पढ़ाऊंगा अभी इस टॉपिक के बाद ही कैपेसिटेंस आएंगे। So this is you can solve this one, और चैट बॉक्स में आंसर लिख दीजिएगा, ठीक है। Now nowadays one more question is found that if there are 3, if instead of 2 there are 3 point charges, तो अगर 3 point charge है, if there are 3 point charges, ये वाला तो 2 point charge के लिए है, अगर 3 point charge है, 3 point charges are there, say this one, this is q1, say this is q2 and say this is q3। अगर ऐसा है कि इन दोनों q1 और q2 के बीच में डिस्टेंस r12 है, q1 और q3 के बीच में डिस्टेंस r13 है, और q2 q3 के बीच में डिस्टेंस r23 है, इस स्पेस में है, ऐसे स्पेस में रखा है, सबका पोजीशन वेक्टर भी कुछ होगा, लेकिन वो देने से कॉम्प्लिकेटेड फिगर हो जाएगा, ऐसे हम लोग मान के चलते हैं। सो टोटल पोटेंशियल एनर्जी ऑफ द सिस्टम और ऑफ दिस 3 पॉइंट चार्जेस, ये फॉर्मूला जिसको याद रहेगा इसी को आगे बढ़ाते जाना है। ये तो Q1 और Q2 के बीच में, तो ऐसे प्लस K देके नेक्स्ट है, सपोज थर्ड चार्ज Q3 लाया गया, तो ये थर्ड चार्ज Q1 के साथ भी एक एनर्जी बनेगा, Q2 के साथ भी एक एनर्जी बनेगा। सो ये दोनों के बीच में होने से Q2 और Q3 का फॉर्मूला लिखने से K Q2 Q3 डिवाइडेड बाय R23 प्लस इन दोनों के बीच में एनर्जी K Q1 Q3 डिवाइडेड बाय R13। ये वाला फॉर्मूला आप लोगों को याद रखना है। ये वाला फॉर्मूला डिराइवेशन नहीं चाहिए आपको, डायरेक्ट फॉर्मूला पूछा जाएगा। राइट द एक्सप्रेशन फॉर द पोटेंशियल एनर्जी फॉर ए सिस्टम ऑफ 3 पॉइंट चार्जेस। ये वाला फॉर्मूला आप लोगों को बाय हार्ट करना है, ठीक है? यू कैन नोट इट डाउन। Now, let us quickly start capacitance. Or before that, one more topic is there. Let me discuss it. Equipotential surface. Equipotential surface में the name itself says that equipotential surface, the surface where the potential remains always same. तो एक पॉइंट चार्ज के लिए r डिस्टेंस में पोटेंशियल हर जगह पे इक्वल होगा। सो पॉइंट चार्ज के लिए पोटेंशियल इक्विपोटेंशियल सरफेस बिकम्स स्फेरिकल वन। तो ऐसे और थोड़ा डिस्टेंस बढ़ा दो तो दिस, और थोड़ा डिस्टेंस कम कर दो तो ऐसे। तो फॉर पॉइंट चार्ज द इक्विपोटेंशियल सरफेसेस आर स्फेरिकल इन नेचर। एंड देन इफ द चार्जेस आर एट इंफिनिटी, अगर चार्ज इंफिनिटी में है, चार्ज अगर इंफिनिटी में है तो पोटेंशियल देखो, इक्विपोटेंशियल सरफेसेस ऐसे ऐसे स्फेरिकल होते होते जब इनफाइनाइट डिस्टेंस होगा तो इट दे सीम्स लाइक प्लेन वन। So for if the charges are at rest, the equipotential surface becomes plane one. It becomes plane one. Then for two equal charges, the a positive charge है सब, अगर if this is the equipotential surface for this one and for this one also it is one, or by doing some numerical we can find the combination, and the combination comes out like this one if the charges are similar charges, if the charges are similar. And जो dipole अभी पढ़े थे, for dipole the for it is positive, say sorry it is negative and this is charge. इन दोनों के लिए भी if this is the potentials, equipotential surface for this one and for this one it is like this. और दोनों का कंबाइन अभी अभी थोड़ी देर पहले पढ़े थे कि दोनों के बीच में जो सेंटर से जो लाइन है that is the equatorial line, वहां पे तो पोटेंशियल 0 वोल्ट 0 वोल्ट 0 वोल्ट. So this is also one of the equipotential surface. So these are the 4 figures that are required. So point charge, charges at infinity, and two equal or not necessarily equal, for two similar charges this is the shape of the equipotential surface, and for a dipole this is the shape of equipotential surface. ये थोड़ा practice कर लेना. So next someone has asked me to teach capacitance. So capacitance, the name comes from capacity. The word capacitance comes from the word capacity. So if we go on giving charges to a, अगर चार्ज देते जाएंगे तो उसका, if I keep on giving the charge to a point, its potential is rising. तो कैसे? क्योंकि V is equal to K Q by R, जितना पोटेंशियल उतना ही बढ़ता जाएगा. तो ability of a conductor to store charge is called its capacitance. The ability to store electric charge by a conductor is called its capacitance. So यहां से पता चल रहा है कि जितना Q बढ़ता जाएगा, Q जितना बढ़ता जाएगा पोटेंशियल उतना ही बढ़ता जाएगा. So I can write Q is directly proportional to V. जितना चार्ज बढ़ेगा उतना पोटेंशियल बढ़ेगा. So Q is proportional to V. Is it clear? Now Q can be written is equal to a constant term C into V. That C is called the capacitance mathematically. So that means C is equal to Q divided by V. So if V is equal to 1, तो C becomes say Q. तो यहां से हम लोग मैथमेटिकली डिफाइन करेंगे जे द कैपेसिटेंस ऑफ ए कंडक्टर इज द अमाउंट ऑफ चार्ज स्टोर्ड टू रेज इट्स पोटेंशियल बाय 1 वोल्ट और रेज इट्स पोटेंशियल बाय यूनिट अमाउंट. अगर एक कंडक्टर का पोटेंशियल यूनिट अमाउंट बढ़ाना है तो उसके लिए कितना चार्ज चाहिए? दैट चार्ज इज गिविंग इट्स कैपेसिटी और कैपेसिटेंस. तो दिस इज द मैथमेटिकल डेफिनेशन. तो ऐसे एकदम सिंपल में अगर जानना चाहोगे तो एबिलिटी ऑफ ए कंडक्टर टू स्टोर इलेक्ट्रिक चार्ज इज कॉल्ड इट्स कैपेसिटेंस. और मैथमेटिकली कैसे डिफाइन करेंगे? इट इज डिफाइंड एज द चार्ज स्टोर्ड पर यूनिट पोटेंशियल डिफरेंस. तो कितना चार्ज स्टोर कर रहा है एक यूनिट पोटेंशियल डिफरेंस क्रिएट करने के लिए, दैट अमाउंट ऑफ चार्ज गिव्स इट्स कैपेसिटेंस. नाउ अगर चार्ज अगर 1 कूलम है और पोटेंशियल अगर राइज हुआ है 1 वोल्ट, तो दिस 1 कूलम बाय 1 वोल्ट इट इज कॉल्ड 1 फेराड. तो ऐसा यूनिट ऑफ कैपेसिटेंस इज कॉल्ड फेराड. इट इज कॉल्ड फेराड. तो व्हाट इज इफ वी आर आस्क्ड व्हाट डू यू मीन बाय 1 फेराड? फेराड मींस द इफ 1 कूलम चार्ज raises the potential of a conductor by 1 volt, then its capacitance is 1 farad. So other units are microfarad is there. Micro means 10 to the power minus 6 farad. Then double microfarad उसको picofarad भी कहा जाता है. Picofarad मतलब double micro, that is 10 to the power minus 12 farad. These are the things you have to know, that microfarad is 10 to the power minus 6. Picofarad मतलब डबल माइक्रो, तो 10 to the power minus 6 minus 6, so 10 to the power minus 12 farad. These are the things related to capacitance. So there the topic for us is the parallel plate capacitor. Parallel plate capacitor, if we that topic is important for our syllabus. So suppose there is a conductor A and B. Okay, not about B first, पहले A पकड़ लेते हैं. So suppose दे रहा हूँ चार्ज से पॉजिटिव चार्ज, तो इट्स पोटेंशियल राइजेस एंड एक टाइम ऐसे आएगा कि इसका पोटेंशियल और नहीं बढ़ा सकते हैं, क्योंकि वी कैनॉट, दिस कंडक्टर इज अनेबल टू होल्ड द चार्ज फर्दर. लेकिन सपोज वी विश, so that we wish that this conductor should contain more and more charges. उसके लिए मुझे क्या करना है? Let us bring another conductor nearby this conductor A. So that conductor is say B. The moment when B is brought nearby it, तो इसका nearer side of B the negative charges will appear, ना? And on the other side positive charges will appear. This is due to the process is called induction process, because they are separated by a distance, so no conduction is possible. So induction के वजह से on this side negative charges will appear, on this side positive, and when this outer side is grounded, charges will flow to the earth, isn't it? So now see the system consisting of a positive as well as negative. पहले ये सिंगल था जिसका पोटेंशियल मैक्सिमम बना था, अभी ये निगेटिवली चार्ज एक कंडक्टर आ गया तो इसका पोटेंशियल तो निगेटिव है, तो एज ए रिजल्ट द टोटल पोटेंशियल ऑफ द सिस्टम विल डिक्रीज। एज ए रिजल्ट पहले सिंगल ए था, पोटेंशियल मैक्सिमम बना था, अभी तो एक निगेटिवली चार्ज रॉड आ गया सामने, तो इसके लिए भी पॉजिटिव, इसके लिए निगेटिव आ गया, तो दोनों मिलके टोटल पोटेंशियल शुड डिक्रीज। तो अगर पोटेंशियल डिक्रीज हो गया तो आई कैन गिव अगेन चार्जेस टू कंडक्टर ए। So this process or this arrangement, the arrangement of two metallic conductors in such a way that one of the conductor has the ability to store charges, more and more charges, when the other conductor is grounded, is called a parallel plate capacitor. This is the technique कि दोनों कंडक्टर यूज करने का कारण क्या है, क्योंकि एक पॉजिटिवली चार्ज है तो दूसरा निगेटिवली चार्ज, और निगेटिवली चार्ज प्लेट के वजह से, yes, about capacitor, how to store, I am coming to that fact. So this process, the arrangement of two metallic conductors in such a way that one of the conductor has the ability to store more and more charge when the other is grounded, and this system is called parallel plate capacitor. तो अगर दिस इज ए पैरेलल प्लेट कैपेसिटर, दोनों प्लेट का अगर एरिया है, दोनों के बीच में डिस्टेंस अगर d है, then if the space between them is air or vacuum, so in that case the capacitance comes out C is equal to epsilon naught A by D. So that derivation part you just go through your book, that capacitance of this parallel plate capacitor comes to epsilon naught A by D, where A is the area of the plate, D common area, then D is the distance between the two plates. Okay, so this is the formula for capacitance of a parallel plate. Next, as one of the school is asking about the energy stored. So as I said, what is potential energy of a system? In this case, to store charge, we need a outside connection, which will be sending the charges. So this cell which is sending, so this cell is doing the work in sending the charges to the plates. So in last topic, in case of dipole, as I said that the amount of work done in rotating a dipole is stored in the form of potential energy. Here also, in case of capacitor, parallel plate capacitor, the amount of work done in storing the electrical charges, by whom, that is missing in our book. कौन वो कर रहा है? The electric cell, the outside source, which is sending the charges. So the amount of work done in storing the charges between the charges on the two plates of a capacitor by, bracket में लिख सकते हो, by the outside source, is stored in the form of potential energy. It is stored in the form of potential energy of the parallel plate capacitor. So this formula I can find it out. We can find it out that at any instant, suppose this cell is sending charges. At any instant, suppose q amount of charge दोनों प्लेट में है. So and दोनों के बीच में potential difference v है. In that case, the potential is, I can write q by c. It is q, as थोड़ी देर पहले पढ़ा था, q is equal to c into v, अभी पढ़ा था. तो potential difference between the two plate is q by c. So suppose at that instant this cell is sending a few more charge, dq amount of charge और भी send कर दिया already. dq amount of charge send कर दिया. To send this charge, this cell has to do work. As I said, the amount of work done in charging a capacitor, कौन कर रहा है? By this cell. is stored in the form of potential energy. So this cell is sending suppose dq amount of charge. So the small work done, it is work done, I can write it is v into dq. कैसे? तो अभी अभी कल से पढ़ा रहे थे कि पोटेंशियल का डेफिनेशन, आज सुबह सॉरी आज ही थोड़ी देर पहले पढ़ाया था, पोटेंशियल इज वर्क डन पर यूनिट टेस्ट चार्ज. तो वर्क डन इज टेस्ट चार्ज इनटू पोटेंशियल. तो यहाँ पे टेस्ट चार्ज लेट अस टेक dq बिकॉज दिस सेल इज सेंडिंग dq. तो dq हो गया की जगह और v इनटू dq. और इस ए भेजने के लिए वर्क डन हुआ है dw. So dw becomes v dq. तो total work done मुझे चाहिए which is called the potential energy and it is integration dw. Suppose a cell capital Q amount of charge भेजना चाह रहा है. शुरुआत में 0 था तो 0 to capital Q कर देना है. तो it is integration dw मतलब v dq यहाँ पे है. तो 0 to capital Q. तो लेट अस मूव. आप नीचे होने से आप लोगों को मुश्किल होगा तो मैं थोड़ा ऊपर कर रहा हूं अभी. हाँ ऊपर मैं ऊपर कर रहा हूं. सो दिस पोटेंशियल एनर्जी व्हिच इज द वर्क डन, सो इट इज इंटीग्रेशन v dq. v मतलब अभी अभी था q by c. सो इंटीग्रेशन इट इज q by c dq एंड 0 टू कैपिटल Q. तो नीचे आ गया इंटीग्रेशन q dq. ए करने से 1 by c इट इज q स्क्वायर by 2 एक आएगा एंड लिमिट इज 0 टू कैपिटल Q. तो 0 का यहाँ पे डालने से तो 0, लेकिन अपर लिमिट डालने से आंसर कम्स कैपिटल Q स्क्वायर by 2c. सो दिस इज द एक्सप्रेशन फॉर पोटेंशियल एनर्जी ऑफ ए पैरेलल प्लेट कैपेसिटर. हाँ नेक्स्ट. ओके थैंक यू. अभी तो नेक्स्ट वही टॉपिक आ रहा है डाइलेक्ट्रिक. About dielectric, about the potential energy of a electric of a parallel plate capacitor. Next comes the dielectric. Is it clear? I think so. और एक टॉपिक था जिसमें between the parallel plate capacitor, if we insert a slab, dielectric slab. So before starting that one, regarding the dielectric, we know that in case of a dielectric, suppose if a dielectric is placed in an external field E0, the negative charges are coming to this side, positive side, and positive charges goes to the other side of the field and creating an polarized field between the within the conductor. The net electric field becomes the external field minus the polarized field. So this is not equal to 0. This polarized field is very less in compared to the external field. So there is a net electric field along the direction of the external field. It is not equal to 0 in case of dielectrics. So dielectrics are insulators. Somebody may be thinking, what is a dielectric? A dielectric is an insulator, but the difference is that in presence of external field, it becomes polarized. Means it allows the electric field to pass through. So best example is our air. Our air is not an insulator because air is a dielectric, because in thundering we see that electricity passes through our air. So during thundering there occurs a very high electric field between the clouds and our earth, and in that process the air allows the charges to pass to our earth. So this verifies that air is not an insulator but it is a dielectric. So dielectric is an insulator, but the condition is that under a high electric field or under a given electric field it allows the electric field to pass through. Now so in when we put a dielectric, the electric field becomes the net electric field E is equal to E0 minus EP. So the ratio before starting this topic, the ratio between the applied electric field divided by this modified which is E is equal to E0 minus EP. This modified ratio of this external electric field and the modified or net electric field is called dielectric constant. ये वाला मुझे चाहिए इस टॉपिक में, तो इट इज कॉल्ड डाइलेक्ट्रिक कांस्टेंट. तो ये वाला मुझे इसमें चाहिए. तो नाउ लेट अस स्टार्ट के सपोज there is a parallel plate capacitor with air or vacuum in between them. So the electric field is from positive to negative side of this plate. So the electric field, suppose it is E0. This electric field is E0 and it can be written as E0 is equal to I can write it as this electric field within the plate. It is yesterday one numerical is there in chapter 1 that between two plates the electric field, if I consider this as a plane sheet, for this here the electric field is E is equal to sigma by 2 epsilon naught, and for this one also here the electric field is sigma by 2 epsilon naught. तो दोनों मिलके electric field becomes sigma by epsilon naught, where sigma is the charge density. Don't be fear that यहाँ पे अगर यूनिट पॉजिटिव चार्ज है तो ए वाला पॉजिटिव चार्ज इसको यहाँ पे रिपेल करेगा, तो इलेक्ट्रिक फील्ड इज अलोंग दिस डायरेक्शन फॉर दिस प्लेट, एंड फॉर दिस नेगेटिवली चार्ज प्लेट आल्सो इट इज अलोंग दिस डायरेक्शन. दोनों इसीलिए ऐड हो गए, इट इज सिग्मा बाय 2 एप्सिलॉन नॉट प्लस प्लेट इज सिग्मा बाय 2 एप्सिलॉन. दोनों जुड़ के आंसर कम्स सिग्मा बाय एप्सिलॉन नॉट. So this sigma, as it is called charge density, so E0 is equal to Q by A epsilon naught. Charge density मतलब charge per unit area. This much from this topic. And between the potential, potential, we know that electric field is equal to dV by dr. अभी आज ही पढ़ाए थे relation between electric field intensity and potential. अगर मैं मैग्नीट्यूड ले लिया तो माइनस साइन नहीं चाहिए, तो E इज इक्वल टू dV by dr. सो यहाँ पे E इज इक्वल टू dV मतलब इन आवर केस इट इज V. It is our case, it is the potential difference V, and distance is, as I said, the distance between the two plate is D, so I can write it as V by D. So this E0 can be written also as V by D. तो यहाँ पे मैं डाल देता हूँ, it is V by D. It is V by D, and it is Q by epsilon naught. Okay, I am going into another track. Actually, I am going to that much is not necessary because we are using the dielectric that is known to us. We will think that it is known to us. तो यहाँ से actually Q by V आने से वो actually capacitance आ जाएगा epsilon naught A by D. So it is the original capacitance here. Now we are putting a dielectric here. Say this is a dielectric slab whose thickness is T. Now here is the answer. When the dielectric slab is put here, so here this side is positive, so here the negative charges will appear, and this side the positive charges will appear. So this because of this dielectric, a net electric field, which is called polarized electric field, is developed within the slab. But the outside the electric field, as I said, when it is here, the electric field, so it is this EP is developed against E0. So as I said, EP is very less than E0. So the net electric field E is equal to E0 minus EP. E0 minus EP. So here again that formula, the dielectric constant, it is E0 by E. ये वाला मुझे चाहिए यहाँ पे. अभी पहले तो पोटेंशियल क्या था, V is equal to जैसे मैं पोटेंशियल अभी जो फॉर्मूला था V E is equal to V by D. तो when there is no slab, E is equal to V by D, इसका मतलब पोटेंशियल इज इक्वल टू E इंटू डी, E इंटू डी था। लेकिन अभी डाइलेक्ट्रिक स्लैब जिसका थिकनेस T है, when we are putting that slab having thickness T, तो अभी within this thickness the electric field is this one, electric field is E, and outside the electric field is E0, sorry this one E0. So here the modification comes. So can I write like this? Can I write like this in this case? For the second case, as V is equal to, initially जब स्लैब नहीं था, V is equal to E0 into D, अभी H modify हो गया कि E0 है, अभी कौन सा जगह पे E0 है, except this thickness T, remaining sides we are having electric field E0, remaining side is air or vacuum, so I can write E0 D minus T, जो remaining thickness है D minus T, और प्लस, और इस T thickness में इलेक्ट्रिक फील्ड तो E है, E, और the thickness is T, E into T, so I can write the modified potential is E0 D minus T plus E। अब थोड़ी देर पहले पढ़ाया था इलेक्ट्रिक कांस्टेंट K इज इक्वल टू E0 by E होता है, तो E के जगह कैन आई पुट E0 by K, E0 by K into T. So this is the modification in the electric potential when a dielectric slab is put there. So when I solve this one, solving part is very easy. तो अगर solve करोगे, the answer comes that the new original capacitance तो C0 था, तो new capacitance comes C0 divided by 1 minus T by D, bracket 1 minus 1 by K. This answer comes that new capacitance is C0 original capacitance divided by 1 minus T by D, 1 minus 1 by K. So there is a modification, and see in the denominator part of right hand side 1 minus something is there, 1 minus C0, 1 minus something, मतलब in the denominator part it is a fraction, decimal value. So as a result, if I calculate that, it comes that C by C0, it comes always greater than 1. So इसीलिए the capacitance is C is always greater than C0. So that means when we put a dielectric slab in between the two plates of a capacitor, the capacitance of that plate increases. Capacitance. Okay. Now the one from my side. Suppose one question is there. My side. Suppose the thickness of the plate is 50% of D. 50% of D अगर है, जो प्लेट सेपरेशन के साथ, अच्छा पहले ए वाला नहीं, पहले मैं ले लेता हूं कि पूरा प्लेट, दोनों प्लेट के बीच में मैं डाइलेक्ट्रिक स्लैब दे दूं, तो इसका मतलब डी T इज इक्वल टू डी, तब ए वाला आंसर क्या होगा? Somebody please give the answer on the chat box. अगर T इज इक्वल टू डी है, मतलब दोनों प्लेट के बीच में पूरा डाइलेक्ट्रिक स्लैब है, सो यहां पे फॉर्मूला डाल दो, यहां पे फॉर्मूला डाल देने से C is equal to C0, 1 minus T is equal to D, so it is 1 into 1 minus 1, then minus 1 by K. देखो 1 कैंसिल, तो K ऊपर चला जाएगा, तो C is equal to K into C0. तो यहां से भी देखो डाइलेक्ट्रिक कांस्टेंट का एक डेफिनेशन आ जा रहा है, K is equal to C by C. ये वाला फॉर्मूला आप लोगों को याद रखना है, Next, my question is if T is equal to 50% of D, अगर होगा तो वो जो थिकनेस है डाइलेक्ट्रिक स्लैब का, वो थिकनेस अगर वो सेपरेशन का 50% होगा तो कैपेसिटेंस, नया कैपेसिटेंस कितना बन जाएगा? ये फॉर्मूला बाय हार्ट होना है। हाफ ऑफ डी होगा। ये करने से आप लोगों को आंसर मिल जाएगा, आप लोगों को आंसर मिल जाएगा C इज इक्वल टू C0/1 माइनस टी, मतलब d डिवाइडेड बाई 2, और नीचे एक d है तो d d कैंसिल, तो t/d मतलब हाफ, 1 माइनस 1/t, तो C इज इक्वल टू C0/1 माइनस हाफ, ये हाफ हो गया, माइनस माइनस प्लस 1/2k, तो 1 माइनस हाफ मतलब यहां से एक हाफ आएगा, यहां से एक हाफ आएगा, तो C इज इक्वल टू C0, यहाँ पे 2 और 2k के बीच में एलसीएम लेने से 2k, तो ऊपर k प्लस 1, तो ये उसको ऊपर लेके जाते हैं, तो C इज इक्वल टू 2k ऊपर चला गया, C0/k प्लस 1। तो ऐसे करके आंसर हम लोग निकाल सकते हैं, ये न्यूमेरिकल पार्ट के लिए इजी रहेगा। और एक होमवर्क ले सकते हो, t इज इक्वल टू 2/3 d होने से क्या होगा, ये होमवर्क है। हाँ, t इज इक्वल टू 2/3 d होने से क्या हो जाएगा? So this is all about the important topics of electric potential and capacitance. Let us go to the next chapter, which is called, because time is short, let us start quickly the electricity, current electricity, or so we will be discussing about drift velocity first. Drift velocity of electrons, it is a known topic to you all, and it is very very important topic. You will all go through this topic, and that drift velocity of electrons when in a conductor, when electrons move from negative side to the positive end of the conductor, they suffer some drift against the electric field, na? So that the motion, the actually the electrons are moving with a very large speed, but because of the number of collision, their speed is reduced to a very minimum low value, and that velocity with which the electrons move against the electric field is called drift velocity, and that drift velocity comes out for a electron, it comes out small e capital E by m into tau. So this I am discussing it quickly, that when the electrons are moving, they move in a zigzag path, and this shows that they are suffering a number of collisions with the neighboring electrons or ions or even the atoms, and because of that their acceleration reduces continuously, and the path is not so smooth, path is not so smooth. So between two consecutive collision, the time taken between two consecutive collision is called the relaxation time. The average of all such relaxation times is called average relaxation time. This tau indicates the average relaxation time. So, and E is the electric field. E is the electric field, and M is the mass electron. So, this drift velocity is important topic. You should know this, that one, and derivation you just go through it. So, drift velocity of an electron in a conductor is E capital E by M into tau. And there is one more generally asking relation between current and drift velocity. Relation between current and drift velocity. That वो वाला फॉर्मूला आप लोगों को याद रखना है कि drift velocity Vd is equal to current divided by NIA. NIA. This formula NIA. NEA. NIA. N मतलब number of number density of the electron, that is N is actually number of electrons per unit volume of the conductor. E is the charge of the electron, A is the area of cross section of the conductor. So here what is called current density. It is called current density denoted by J. So J is Vd. So okay, one more thing, current density is taken as a vector quantity. Though current is a scalar quantity, but current density is a vector quantity. The reason is that current density definition of current passing through a given area when it is held normally to the flow of the path. अगर normally है तो the I am indicating the fixed direction. So that's why current density is a vector quantity, but current is a scalar quantity. So current density can be written as current per unit area. तो इस फॉर्मूला से नेवा ड्रिफ्ट वेलोसिटी मतलब है स्मॉल ई कैपिटल ई by m into tau. So I can write it as n square capital E by m into tau. This is one more, and we will be इस बार प्री बोर्ड में एक क्वेश्चन आया था कि यूजिंग दिस रिलेशन बिटवीन करंट एंड ड्रिफ्ट वेलोसिटी ऑब्टेन ओम्स लॉ. याद आया? एक क्वेश्चन आया था प्री बोर्ड में कि ओम्स लॉ भी वेरीफाई करना है यूजिंग द फॉर्मूला ऑफ ड्रिफ्ट वेलोसिटी एंड रिलेशन बिटवीन ड्रिफ्ट वेलोसिटी एंड करंट. तो यहां से भी मिल जाएगा. सो लेट मी चेक. करंट इज इक्वल टू एन ई velocity into E, neva. So current can be written as NE, drift velocity small e capital E by m into tau into E. Now current is equal to N, and if L is the length of the conductor, L is the length of the conductor, और उसमें इलेक्ट्रिक फील्ड अगर E है, so I can write V is equal to E by L. कारण V is equal to E by V is equal to because we know that E is equal to dV by dr, so E is equal to V by N. तो L लिख सकता हूं ना. So current, is equal to N square. E के जगह में V by L लिख दिया. इधर टाउ A और इधर M ऑलरेडी है. ओके, सो देखो I और V आ गया, तो ऑलमोस्ट ओम्स लॉ में हम लोग पहुंच ही गए. तो V और I मुझे अलग करना है. तो सी आई कैन राइट V इज इक्वल टू और V डिवाइडेड बाय I. V के नीचे I लेके जाते हैं और ये सब सारा इधर आ जाएगा. ML ऊपर नीचे N E स्क्वायर टाउ ये सब नीचे आ गया. तो सी हियर at a given temperature and pressure, all these quantities on the right hand side are constant. At a given temperature and pressure, all these quantities on the right hand sides are, because m is the mass of the electron, L is the length of the conductor, A is the area of cross section, N is number density, small e is charge, and tau average relaxation time at a given temperature and pressure is also constant. So this is all things on the right hand sides are constant. So I can write V by I is a constant term. So V is proportional to I, which is Ohm's law. तो ये वाला स्टेप आप लोगों को थोड़ा प्रैक्टिस करना है. ठीक है? It is also important for this coming board exam. So this was about current electricity, this important topic. And then resistor is there. You can be knowing that this is one kind of resistor. It is one kind of resistor. It is a wire bound resistor. And there is nowadays we are using color code resistor. Here this wire has got a fixed resistance. But nowadays these we are not using. Nowadays color code resistors are used. I have one for you, but it is in a circuit. A small circuit is there. I am having with me this one. This one is the color code resistor. Okay, and this is one kind. This device, it is called diode. It is light emitting diode, and this one, it is not there in our syllabus. It is a transistor, but it is not there in our syllabus. But I am talking about this one. 3 colors are there. So it is called carbon resistor or color code resistor. So about resistor, we know that in this current electricity, this phenomena is to pass through a conductor. When it wants to pass through from one end to the other conductor, it has to be opposed by the conductor, and that opposition, net opposition, is called the resistance. So I used to teach my students like that, or has got its resistance. So a conductor having an appreciable value of resistance is called a resistor. एक कंडक्टर जिसका रेजिस्टेंस हमें पता है तो उसको हम लोग कंडक्टर ना बोल के रेजिस्टर भी बोल सकते हैं. बिकॉज व्हाई? बिकॉज इट हैज गॉट ए रेजिस्टेंस. इट हैज गॉट ए रेजिले, उसको कंडक्टर का नाम हम लोग करंट इलेक्ट्रिसिटी में रेजिस्टर दे सकते हैं. तो उस दैट रेजिस्टर इज denoted by the symbol like this one. This resistor is denoted by the symbol this one. So R means it is a conductor having resistance R. So when these two or more resistors are connected, in series, the net resistance is sum of all these resistances. Net resistance is sum of all these resistances. And अगर पैरेलल में लगाएंगे, द एंड्स आर कॉमन, मुझे एंड्स को कॉमन करना है. दिस वन, it is R1, it is R2, like that. One more you can have. So like that, if a number of resistors R1, R2, R3, etc. are connected in parallel, the net resistance comes out to be 1 by R. It is equal to 1 by R1 plus 1 by R2 plus dot dot dot. जितना होगा ऐसे. तो सीरीज में है R is equal to R1 plus R2 plus dot 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 like this. लेकिन यहाँ पे एक चीज बता देता हूँ, सेकेंड चैप्टर में मैं स्किप किया हूँ. कैपेसिटर्स कैन ऑल्सो बी कनेक्टेड इन सीरीज एंड पैरेलल. उसमें इसका उल्टा, एग्जैक्टली उल्टा होगा. तो एक जैसे सीरीज में है और ये पैरेलल में है. इन केस ऑफ कैपेसिटर, इन कैपेसिटर्स में उल्टा हो जाएगा. कैपेसिटर्स में उल्टा कैसे? कि सीरीज में हो जाएगा नेट कैपेसिटेंस इज लाइक दिस, 1 by C is equal to 1 by C1 plus 1 by C2 plus etc. एंड पैरेलल होने से रेजिस्टर का सीरीज जो है वो आंसर होगा. तो C is equal to C1 plus C2 plus like this. तो लेट अस डू वन न्यूमेरिकल. सपोज ये वाला कोई करके दिखा सकते हैं. Suppose there are 3 resistors. You can have this one, this is 1, this is 2, this is 3. So suppose ऐसे दिया हुआ. Can anybody solve? Say this is 9 ohm, this is 9 ohm, and this is 9 ohm. Say this is A and B. What is the resistance between A and B? You can give your answer. So let me discuss that. See, here, let these points are there. So here, see, this end of this resistor, and see, this end of this resistor are common. And here also, similarly, end of this resistor, and end of these resistors by this conductor, they are common. So it is a parallel combination. So since it is a parallel combination, our answer is 1 by R is equal to 1 by 9 plus 1 by 9 plus 1 by 9. So answer is 3 into 1 by 9. So 1 by 3. So 1 by R is equal to 1 by 3. So R is actually 3, like this. Then is it okay? Now, one more important topic in this chapter is Kirchhoff's law. है ना? Kirchhoff's law था, जिसमें first one is called Kirchhoff's current law. Kirchhoff's current law says that the number of currents meeting at a point, number of currents I1, I2 suppose आया, तो I3 निकल गया, I4 भी निकल गया और I5 भी निकल गया. So the number of currents meeting at a point is always 0. The sum of the currents meeting at a point is 0. तो I1 plus I2 is equal to, वो दोनों करंट O पॉइंट में आया और ऐसे I3, I4 and I5 निकल गए. So if I bring all these to I1 plus I2 plus minus of I3 plus minus of I4 plus minus of I5, ऐसे लिख सकता हूं मैं. So that means sum of all the currents meeting at a point is called Kirchhoff's current law. Kirchhoff's current law चाहिए. Then Kirchhoff's voltage law is also there, and Kirchhoff's law is generally used for complex electrical circuit. For a very simple electrical circuit, Ohm's law is sufficient. But if the circuit is a complex one, we can use Kirchhoff's voltage law. So Kirchhoff's voltage law is like this one. Suppose we have to take say cells E1, E2 are there, say two cells are there like this one, they are in series and they are connected to a complex circuit like this one, say one, and this is another one. For our study purpose, say this is R1, this is R2, this is R3. So this is plus minus like this one. So here see the cell is sending a current and that current is divided into two. Say this is I1 is entering here and I2 is coming to this one. So here say I current आ रहा था, ठीक है. So this I1, see here we can use the current first law of Kirchhoff's first law, that current entering at this point is divided into two. So I1 plus I must be is equal to I1 plus